So we've seen how to solve equations that involve quadratic functions. In other words, we've solved quadratic equations. Now, how do we solve an inequality that involves quadratic functions? So the method I use is I first solve the corresponding equation, and then I draw a number line, and I mark any solutions that I obtained from solving the equation onto that number line. That will give me some intervals. Now, on the intervals, I will either satisfy the inequality or I won't. So what we will do is we will choose a test value on each interval to determine whether or not the test value, which is representative of the entire interval, will satisfy the original inequality. So we substitute the test value into that original inequality, and if that original inequality is made true by the test value, then that interval satisfies the inequality and it's part of the solution set. And so we would shade that portion of the interval. So let's go ahead and take a look at an inequality. So what we will first do is we're going to solve x squared minus 5x plus 9 equals 2x plus 3. So let's go ahead and solve this equation. We will subtract 2x from both sides. We will subtract 3. And the goal here is that we are solving the equation by setting it equal to 0. So we can solve this by factoring. So we have x and x, and then we have a positive 6, so the signs will be the same, and we will choose the sign of the negative 7. Now, how will we break up 6? We could try 2 and 3, or 1 and 6. So let's go ahead and, if we FOIL that out, we would see that x minus 1 times x minus 6 is correct. So x minus 1 equals 0, or x minus 6 equals 0. So this tells us x equals 1, or x equals 6. So that is the solution of the equation, not the inequality, but the equation. So here's a number line, and I'm going to put 1 and 6 in order on that number line. Now you'll see that we have 3 intervals. So let's go ahead and choose values on each interval. So to the left of 1, I can choose 0. Between 1 and 6, we can choose any value. I'll choose 2. And to the right of 6, I'll choose 7. And now what I'm going to do is I'm going to look at the original inequality, x squared minus 5x plus 9 is greater than 2x plus 3. Now, we will take 0 and we will plug it in for x into this original inequality, I should say. So we get 0 squared minus 5 times 0 plus 9, so this would be 9, is greater than 3. And that is true. Now, substitute 2 in. We would get 4 minus 10 plus 9, that's 3, is greater than, and now put in 2 onto the right side, and we get 7. So now we will put 7 in. And so 7 squared minus 5 times 7 plus 9, that gives us 23. And then we have 2 times 7 plus 3 is going to be 17. So this is false and this one's true. And so we will shade the true portions. Now the question is, what about 1 itself? If I put 1 in, that would make this equal to 2x plus 3. So we should not include it. And likewise, if we put 6 in, it will give us equality. So we should not include it. So therefore, our answer is negative infinity to 1 union 6 to infinity. So now let's take a look at our next example. Again, let's solve the corresponding equation. X squared minus 6x plus 9 equals negative x squared plus 3x plus 2. If we add x squared and subtract 3x and subtract 2 from both sides, we would get 2x squared minus 9x plus 7 equals 0. Now again, this factors. So we have x, we have 2x. The signs will be the same. They'll both be minus. And we will have 1 and 7. So now that means x minus 1 equals 0, or 2x minus 7 equals 0. So x equals 1, or x equals 7 halves. So again, let's draw our number line. 1. Now 7 halves is 3.5. So let's go ahead and check some test values on each one of the 3 intervals. So again, 0. 2 is between 1 and 3.5. And I can choose 4. And we're going to substitute those into the original inequality. So if we substitute 0 in, we get 9 is less than or equal to 2. So 9 is less than or equal to 2. That's false. Now let's substitute 2 in. We would get 1 is less than or equal to, now let's put 2 into the right-hand side. Negative 4 plus 6 plus 2. And that is 4. And that is true. Now let's substitute 4 in. So 4 squared minus 24 plus 9 is less than or equal to negative 16 plus 12 plus 2. So we get 1 is less than or equal to negative 2, which is false. So we shade the region, or the interval, that is true. So between 1 and 7 halves. Now, if we put 1 into our inequality, it makes it equal. So this time we should include it. Likewise, 7 halves would make it equal. How do I know that? I'm not plugging it in. I already know these are solutions to the equation. So therefore, I'm looking at between 1 and 7 halves is my solution, including the 1 and the 7 halves.